Now let us see differentiation of a parametric function. Alright, let's understand what is the meaning of parametric function. Now when y and x are both specified in terms of a third variable called as a parameter, then y is said to be a parametric function of x. That is, if y is expressed as some function of t, say f of t, and x is expressed as some another function of t in general, say g of t, then derivative of y with respect to x is given by dy by dx equal to dy by dt upon dx by dt. So by parametric function we mean that y and x are not expressed in a single equation, but they are expressed indirectly in terms of a third variable called as a parameter. So if we want to find the derivative of y with respect to x, then that is equal to derivative of y with respect to t divided by derivative of x with respect to t. Okay, so that is what is called as the parametric differentiation. Now typically this parameter is denoted by the symbol t or theta or alpha. Okay, these are the typical notations used, but of course it's not mandatory and we have to identify based on the question, that is which is the parameter. And another thing to note is in the formula we have dx by dt in the denominator, so therefore we must have dx by dt as a non-zero expression. Okay, now let us see few questions in which we are to use this particular method. Alright, here is the first question, that is find dy by dx where x is given by a t square and y is given as 2at. Now here as per the convention we have to consider t as the parameter, okay, and a is to be treated as a real constant, right? So therefore let us first write the formula as we know, that is dy by dx is given by dy by dt whole divided by dx by dt. So that is nothing but in the numerator we have to write the derivative of y with respect to t. So if we consider y which is given as 2at, so the derivative of 2a into t will be nothing but simply 2a because it's a constant, and derivative of t is 1 divided by derivative of x with respect to t. Now x is a t square, so the derivative of x with respect to t is nothing but, since a is a constant it will remain outside, and derivative of t square is nothing but 2t. So therefore cancelling 2a, finally we are left with just 1 upon t. So that's the derivative of y with respect to x. Now it will be interesting to note that the derivative of y with respect to x is also expressed in terms of the parameter t only, right? Let us go ahead and see another question. Now this is a slightly different variety. Find dy by dx at theta equal to pi by 4 where x and y are given as shown here. So x is a cos theta plus b sin theta and y is a sin theta minus b cos theta. So the meaning of this particular expression, that is dy by dx at theta equal to pi by 4, means that first we have to find the dy by dx in terms of theta, and then in that replace theta with pi by 4 to evaluate the actual value, right? Now let us first find out dy by d theta. Now as it's clear from the terminology, once again here theta is the parameter and a and b are to be considered as constants because that is a typical convention used. Okay, now let's differentiate y first, that is dy by d theta equal to derivative of a sin theta is a cos theta minus b into derivative of cos theta is minus sin theta. So that turns out to be a cos theta plus b sin theta. Similarly, let's find out the derivative of x with respect to theta. Now x is given by a cos theta, so derivative will be a into derivative of cos is minus sine plus b into derivative of sine is nothing but cos, so that will be b cos theta. So just to rewrite that, it is minus a sine theta plus b cos theta. Now what we want to find is dy by dx, which is given by formula as dy by d theta upon dx by d theta. So that turns out to, we have to simply replace with the required expression, that is a cos theta plus b sin theta divided by, now while writing dx by d theta I will just write in opposite order. I will first write b cos theta minus a sin theta. Now this is the value of the derivative in general, that is in terms of theta, but we are asked to find the value at a particular point, that is dy by dx when theta is given to be specifically pi by 4, and we know that is 45 degrees. So what we have to do is we have to replace theta with pi by 4. So a into cos of pi by 4 is 1 upon root 2, so we know that is a upon root 2 plus b into sine of pi by 4 is once again root 2, so that turns out to be same as 1 upon root 2 divided by b cos of pi by 4, so once again b upon root 2 minus a into sine of pi by 4, which is once again root 2. So if we multiply numerator and denominator by root 2, we will get the answer as a plus b whole divided by b minus a. Or if you just want to write it the other way around, we can write it as b plus a upon b minus a. Right. That's the final answer. Let's see one more variety of the question. Now here we are asked to differentiate tan square x with respect to log x. Now typically we are used to differentiate with respect to just x as the variable. So how come we can differentiate one function with respect to the other function as asked here? So for that what we have to do is, let's visualize this first function as u and second function as nothing but v. So u is a function of x and v is also some function of x, and what we have to find is du by dv, that is what we have been asked. And since u is a function of x and v is a function of x, using the parametric differentiation we can write du by dv nothing but du by dx upon dv by dx. So you see here x itself has to be considered as the parameter. Now du by dx, that is derivative of tan square, that is the square of tan. So using the chain rule, first we write it as 2 into tan x multiplied by derivative of tan x, which is sec squared x, isn't it, whole divided by, now we have to differentiate v with respect to x, and v is log x, so its derivative is 1 upon x. That's it. So if we want, we can take that x in the numerator and we'll have 2x tan x into sec square x. That's the answer.